Hi Mo girl, it's been a minute, I haven't seen you since the week before last, what's up? Hi Mo girl, it hasn't been going well for me, COVID is making things tougher and tougher by the day. When I come back from work, I have to thoroughly bath before hugging my own child. Being a frontliner is really not a child's play. Anyway, enough about my boring life. What about you? I mean concealer, eyebrows on flick, hairline on point. You're like what Cobra likes to say about himself, Cabrizi Wally easy. You are just cruising through this thing called life. This is me being Zodwa from Gumara. Charity begins at house, I mean, of course, like exactly. We need to get back home. Mr. K is about to continue with organic chemistry. I almost forgot, let's get this show on the road.
Hi guys, Dumelang, Sanbonani, Awema Sekenas. I would like to welcome you to another episode of Science Explained with Mr. K. Here we are going to focus on the three homologous series that I've been talking about, which is your alkanes, alkenes, and alkynes. But most importantly, we are going to look into their chemical properties. In grade 11, we looked into the different types of intermolecular forces. And now, because I'm focusing on the alkanes, there's one specific type of force that we're going to look at, which is your van der Waals forces, or the weak van der Waals forces as they call it. Or if you don't want to say weak van der Waals forces, you can always say your London or dispersion forces. We say they are weak van der Waals forces simply because that type of force, it's not necessarily a permanent type of force. It only exists for a certain amount of time, and then the molecules can separate easily, depending of course on the properties, depending of course on the conditions of that particular molecule. But in general, your weak van der Waals forces are very weak. As soon as they are exposed to external factors, then they behave differently.
Thank you, Mr. Kumalo. It is also important to note that we also have vapor pressure, which tells us about the tendency of a substance to easily turn into a gas phase. It is also important to note that alkanes, alkenes and alkynes are all held together by London or dispersion forces. Back to the vapor pressure, so if the intermolecular forces between substances is weak, the vapor pressure is high. But please be aware that as you move from an organic compound with 1 carbon to the one with 8 carbons, the vapor pressure decreases, because as you increase the chain length, you increase the strength of the intermolecular forces, and that decreases vapor pressure.
Mr. K Jr., I also read in my textbook that the melting point and the boiling point also depend on the intermolecular forces, so if I understand what you are saying, alkanes, alkenes and alkynes have London forces, therefore the vapor pressure will be higher, and the energy required to break the bond between molecules is less. So Yvonne, Mr. K Jr. and our viewers out there, I have just one question, in fact 2 questions now that I'm thinking about it. Most of the perfumes have alkanes, and literally petrol is from alkanes, so 1, does this mean if you buy cheap perfumes they'll evaporate faster? And 2, is it advisable to pour petrol during the day when it's hot?
Well, let's let our viewers spend some time on these 2 questions. There's quite a lot of information we shared today, so please take some time to go over everything we discussed today, and from us we'd like to thank you. Till next time, remember to like and subscribe. Thank you. We out.